Okay, good morning. So welcome to, I hope you have with you your modules in science. So this is the second quarter module. Actually, this module is purely activities. Puro ni siya tanan activities. Take note nga, diri mo mag-answer. Kani inyuhang sulatan. No need for a separate answer sheet or a separate paper for your answers. All you have to do is to write down your answers here. Okay? Imanan, sulatan ang modules because these are all activities. Okay. So, for this quarter, we will be, our topic is all about chemistry. Basically, we will tackle the quantum mechanical model of an atom, formation of an ionic bond and covalent bond, properties of ionic and covalent compounds, the properties of metals, carbon compounds, the mole concepts, and the percentage composition. So these are our topics for the second quarter, comprising 5 modules tanan. So imagine 5 modules nara sa isa ka, what is this? Isa ka, murag, isa ra ang nahatag sa inyo, pero these are all activities for the 5 modules. Okay, for today, we will discuss our first topic, which is the quantum mechanical model of an atom. Basically, what you will learn from this module is that you are going to describe the Bohr's atomic model, understand the basic quantum structure of the atom, specifically to atomic energy levels, and explain how the quantum mechanical model of the atom describes the energies and position of the electrons. Okay, recall in your grade 8, okay, you have learned the Rutherford's atomic model which pictures the atom as mostly empty space. And its mass is concentrated in the nucleus, where you find the protons and the neutrons. This model has worked well during his time, but it was only able to explain a few simple properties of atoms. It could not explain why metals or compounds of metals give off characteristic colors. Give off characteristic colors when heated in a flame, or why objects when heated at greater or higher temperatures first glow to red, then to yellow, and then to white. So for example, in the illustration na ay ang lithium, the color of the flame is red. For sodium, yellow. Potassium, na siya pagka purple. For copper, na siya pagka bluish green. So a model different from Rutherford's atomic model is necessary to describe the behavior of atoms. That is why Niels Bohr refined Rutherford's model of an atom. Based on his experiments, he considered the electrons as particles moving around the nucleus in fixed circular orbits. And these orbits are found at definite distances from the nucleus. The orbits are known as the energy levels, which is denoted by small letter n. Okay, where n is a whole number that is equal to 1, 2, 3, so on and so forth. So if n is equal to 1, that is energy level 1. If n is equal to 2, that is energy level 2. 3, energy level 3, so on and so forth. Now, electrons in each orbit have definite energy, which increases as the distance of the orbit from the nucleus increases. Now, as long as the electron stays in its orbit, okay, as long as it stays in its orbit, there is no absorption or emission of energy. Pag naalang siya sa iyang orbit, naalang siya sa energy level 1, okay, dara siya, nagatuyok-tuyok sa energy level 1, sa orbit, okay, there is no absorption or emission of energy. As shown in the figure, when an electron of an element absorbs extra energy. Okay. When it absorbs extra energy, this electron moves to a higher energy level. Okay. For example, gikan siya sa energy level 1 and then ni-absorb siya og energy. Pag-absorb niya og energy level, pag-absorb niya og energy, ni saka dayon siya sa energy level 2. So pagsaka niya, pag-absorb niya og energy, so ni adto na siya sa second energy level. At this point, the electron is at its excited state. So when an electron moves from a lower energy level, for example 1, to a higher energy level, for example 2, this electron needs to absorb energy. And this electron is at its excited state. Once the electron is excited, the atom is unstable. The same electron can return to any of the lower energy levels, releasing energy in the form of light with a particular color and definite energy of the wavelength. Okay, the same thing will happen if ang electron na siya sa higher energy level, for example 2, and then mubalik siya sa energy level 1. So, unsay mahitabo? Kung gikan siya sa 2, mubalik siya sa 1, it needs to emit its energy. Iyahang i-release iyang energy para mubalik siya sa lower energy level. Pero kung mo pasaka siya gikan sa 1 or gikan sa lower energy level padulong sa higher energy level, for example 2 or second energy level, it needs to absorb energy. This Bohrs model explained the appearance of the bright line spectrum of the hydrogen, but could not explain for atoms which has more than one electron. Okay, muna siya ang reason why Bohrs model could not explain the atoms that has more than one electron. It could only explain the atoms with atoms like hydrogen. Pero kung daghan na gayud mga number of electrons, okay, dili na maka-explain ang atomic model ni Niels Bohr. So naay limitation ang atomic model ni Niels Bohr. Okay, let's try this. Which illustration below represents the energy level, okay, which represents the energy, of the electron as described by Bohr? Okay, explain your answer. Is it this one? Okay. Kani ba? One or the second illustration? Okay, what's your answer? Okay, very good. The illustration or this illustration represents the energy of the electron as described by Niels Bohr. The energy levels of the electrons are like the steps of a ladder. The lowest step of the ladder corresponds to the lowest energy level. A person, for example, can climb up and down by going from step to step. Okay, the same thing with electrons as described by Niels Bohr. There is from lower energy to higher energy, it needs to absorb. From higher energy to lower energy, it needs to emit. Similarly, the electrons can move from one energy level to another by absorbing or releasing energy. Okay, let's try this. Kaduha. It was New Year's Eve. You were out with your family to the plaza to watch the fireworks show. You were amazed as you took this picture. Okay, di ba? Kung naay mga fireworks, naay red, naay yellow, klase-klase nga mga colors na fireworks display. You remember that the fireworks' ability to produce light is something to do with the state of the electrons. Okay. Which of the following state do electrons can produce light? Okay, explain your answer. Unsa ka nga state? Okay. So, comment your answers. Okay, comment below inyong answer. Dili ko magsaba sa akong answer. You just comment below and then later on, magsaba ko kung unsay answer. Okay? Comment below your answers kung which type of electron can produce light. Okay. Now, Bohr's model of the atom was not sufficient, muna akong giingon kaganiha, to describe atoms with more than one electron. His idea that electrons are found in definite orbits around the nucleus was rejected. Reject kay it could only explain atoms like hydrogen, pero atoms with more than one electrons, dili na applicable ang atomic model ni Niels Bohr. That is why we have three physicists led the development of a better model of the atom. These were Louis de Broglie, Erwin Schrödinger, and Werner Karl Heisenberg. De Broglie proposed that the electron, which is thought of a particle, could also be thought of as a wave. Okay. Muna ang giingon ni, kinsa gayto? Muna ang giingon ni De Broglie that the electron, which is thought of as a particle, could also be thought of as a wave. So, doon siya particle and a wave. Okay. This is also known as the dual nature of an electron, a particle and a wave. Schrödinger used this idea to develop a mathematical equation to describe the hydrogen atoms. Si Schrödinger, iyahang contribution is a mathematical equation to quantify the claim, or to quantify the to quantify the claim of Louis de Broglie. Okay. Schrödinger used Heisenberg, okay, Werner Karl Heisenberg discovered that for a very small particle like electron, its location cannot be exactly known and how it is moving. This is called the uncertainty principle. Muni ang contribution ni Heisenberg because electrons are very tiny particles. Okay. Ingon siya, ang location cannot the location of the electron cannot be exactly known and how it is moving. Okay. These scientists believe that there is only a probability. Okay. Only a probability. Walay kasiguruhan. It's only a probability that the electron can be found in a certain volume in space around the nucleus. And this volume or region of space around the nucleus where the electron is most likely to be found is called an atomic orbital. Okay. This is the region of space around the nucleus where the electrons is most likely to be found. Is called an atomic orbital. Thus, we could only guess the most probable location of the electron at a certain time to be within a certain volume of space around the nucleus. Okay. Now, the quantum mechanical model of the atom comes from the mathematical solution to the Schrödinger equation. Remember that the contribution of Schrödinger is the mathematical equation to quantify the claim of Louis de Broglie. This model views an electron as a cloud of negative charge having a certain geometrical shape. This model shows how likely an electron could be found in various locations around the nucleus. However, the model does not give any information about how the electrons moves from one position to another. Okay. This figure shows that the darker an area, the greater is the probability of finding an electron in that area. Okay. Probability lang. So the darker an area, pasabot ana, greater ang probability nga dira na to makita ang electron. Okay. The quantum mechanical model also gives information about the energy of the electron. The model also describes the region of space around the nucleus as consisting of shells. These shells are called principal or main energy levels. The principal energy levels or shells may have one or more sub-levels. And these sub-levels are assigned with letters S, P, D, F, and G. Okay. Muna iyahang mga sub-levels. Okay. As shown in the table, the principal quantum number always equals the number of sub-levels within that principal energy level. The maximum number of electrons that can occupy a principal energy level is given by the formula 2n squared, where n is the principal quantum number. If the principal energy level is 1, the number of sub-level is also 1. And there are five types of sub-levels. We have the S, P, D, F, and G. Okay. For example, if the principal energy level is 1, the number of sub-level is 1. Okay. Pag 1 nga number of orbitals, so we have S. So, 1s. Take note nga kada orbital, a maximum of 2 electrons can be placed in an orbital. So, isa raman ka orbital, okay, again ha, the principal energy level is 1. The number of sublevels is also 1. So, pag 1 ang number of orbitals, okay, iyahang type of sublevel is S. That is why 1s. Ano siya? 1s. Take note nga, kada orbital, 2 electrons ang pwede maka-occupy. Duha ka electrons ang pwede maka-occupy. That is why, for one orbital, the maximum number of electrons is 2. Sunod, if we have 2 or second principal energy level, if our n is 2, or the principal energy level is equal to 2, therefore, pila ka number of sublevels? Also, 2. Okay. So, we have, kung duha na ka sublevels, we have okay, S and P. So, natay 2S, natay 2P. Take note nga ang 2P, tulo iyahang number of orbitals. So, ang S, isa ka orbital. Ang P, tulo ka orbital. So, si S, pila gani iyang ma-occupy nga number of electrons? Duha. Si P, tulo man yang ka-orbitals times 2. So, pila? 6. Plus, kang S pag yun, which has 2 electrons, so pila na tanan? Okay. 8 electrons. Okay, muna siya. 8. Next, if there are 3, or if the principal energy level is 3, okay, therefore, it has 3 sub-levels. Okay. What are those 3 sub-levels? We have S, P, and D. S, P, and D. Take notes nga, si S, isa lang ka-orbital. Si P, pila ka-orbital si P? Okay, tulo ka-orbital. Si D, pila ka-orbital si D? It has 5 orbitals. Okay, kwenta ta. So si S, isa ka-orbital. So pila ka-electrons? Duha. Si P, duha. Si P, tulo ka-orbital. Pila ka-electrons dapat kada orbital? Duha. So 3 times 2, 6. Okay, 6. Okay. Si 3D, pila ka-orbital? 5. Pila ka electrons kada orbital? Duha. So, pila tanan? 2 times 5, that is 10. Okay, let's add. 2 plus 6 plus 10. That totals to 18 electrons. Okay. That totals to 18 electrons. Next, fourth energy level. So fourth energy level, upat ka sublevels, we have S, P, D, and F. So take note nga si S, isa ka orbital, si P, tulo ka orbital, si D, 5 ka orbital, and this time, si F, 7 ka orbitals. So we have, okay, giada man to sila kaganihan, no? Kung tulo ka orbitals or tulo ka sublevels, yang total electrons kay 18. How about this time kung nadugangan na og 7 ka orbitals? Nya kada orbital na ay 2 ka electrons. So 7 times 2, 14. So 18 plus 14. You do the math. 18 plus 14, okay, that is 32. The same thing will happen if, okay, nanata sa ika-fifth energy level. Fifth energy level, pasabot 5 ka sublevels. So 5S, 5P, 5D, 5F, and 5G. So sa 5G, doon na siya 9 ka-orbital. So 9 ka-orbital times 2, that is 18. So 32 plus 18, that is, okay, you do the math, that is 50. Very good. Okay, let's try this. Okay, let's try this. O, saan yung pang-delete akong mga gipang sulat-sulat. Okay, practice daw. Okay, if the principal energy level is 2, okay, the number of sublevels is also, okay, the number of sublevels is 2. Okay, the number of sublevels is 2. Okay, the type of sublevels, we have type of sublevels, we have 2S and 2P. 2S and 2P. Now, maximum number of electrons. So 2S, 2P, 2 plus 2P, it has 3 orbitals. So totals to 8 or okay, 8 total number of electrons. Okay. How about this one? 3. So 3, doon na po siya tulo ka sublevels. What are those sublevels? Or I mean, what are the types of sublevels? We have 3S, 3P, and sa sunod 3D. Very good. 3S, 3P, and 3D. Now this time, pila naman tanan ka electrons? So 8 plus ang D, pila gani ka orbitals ang D? It has 5. So 5 times 2, 10. Pila naman tanan? Okay. That totals to 18. That totals to 18. Okay. Okay. So orbitals have specific energy values. They have particular shapes and direction in space. The s orbitals are spherical and p orbitals are dumbbell shaped as shown in figure. Okay, as shown in this figure. Because of the spherical shape of an s orbital, the probability of finding an electron at a given distance from the nucleus in an s orbital does not depend on the direction. Unlike the 3 kinds of p orbitals which are oriented along the x, the y, and the z axis. The different orientation in space are px, py, and pz. And the shape of other orbitals, d and f orbitals, were derived from complex calculation and dili tana ma-discuss for for this lesson because these are very complex orbitals. So what we will focus here is the s and the p orbitals. Okay, in an atom, electrons and the nucleus interact to make the most stable arrangement as possible. And the way in which electrons are distributed in the different orbitals around the nucleus of an atom is called the electron configuration. So recall this in your grade 8, the electron configuration, the distribution of electron in the most stable arrangement as possible. Okay, for example, okay, hydrogen, which has an electron, okay, 1. Element hydrogen with an atomic number of 1. Take note that the atomic number is the number of protons or equal to the number of protons and the number of electrons. So pareho ra ang number of protons and the number of electrons. Okay. Aufbau principle, the lower energy orbitals are filled before higher energy orbitals. So, muni ang Aufbau principle. Magsugod kita sa lower energy level, aya ta mo pataas. Aya ta padulong sa higher energy level. That is the Aufbau principle. And Hans rule, muna itong timanan ha. Hans rule, 1 electron goes into each until all of them are half full before pairing up. So, ang Hans rule, pag naanata sa second energy level, okay, di ba ang second energy level kay, okay, ang second energy level kay duha na ka iyahang type of sublevels, S and P. So, sa P, tulo man na siya. PX, PY, and PZ. So, si PX, unahon sa nato siya, dili nato siya i-pair daan. So, diretso ta sa PX, PY, and PZ, ay ito yung tabalik sa PX. Okay, that is the Hans rule. Okay, later on, ma-discuss ta na para maklaro na to. And then po, Pauli's exclusion principle, no two electrons can be identified by the same set of quantum numbers. Okay, or it must have different spins. So these are the 3 important rules or principles that we are going to follow for electron configuration. The Aufbau principle, the Hans rule, and the Pauli's exclusion principle. Okay, let's try this. Okay. Element hydrogen with an atomic number of 1. Take note that the atomic number is just equal to the number of protons and the number of electrons. Kung pila iyang atomic number, mausad kadaghan na iyang protons and also the electrons. If the atomic number is 2, okay, therefore, pila kabuk iyang protons? Also 2. Pila kabuk iyang electrons? Also 2. If the atomic number is 6, pila kadaghan na iyang protons? Okay, 6. And the electrons, also 6. Okay, let's try this. Carbon has 6 number of electrons. So 6 number of electrons, remember the Aufbau principle, unahon nato ang okay, 1s2, first energy level. So kana pataas, okay, pataas and then paubos. First energy level paman. Second energy level, S pamanta. So paubos. Pipila na tanan? 1, 2, 3, 4. 1, 2, 3, 4. Upat. Pila atong kulang? Okay. The remaining electrons para mabuo nga 6 is duha. So it needs, okay, sa P nga sublevel, there are 3 man. So PX, PY, and PZ. So dili nato punon si PX una. So una ta kang PX, okay, aya din ta kang PY. Okay. So, mao ni siya ang electron configuration for carbon. How about nitrogen? Nitrogen has 7 electrons or has an atomic number of 7. So therefore, it has how many number of electrons? Okay, it's pila? Okay, 7 also. So 7, okay, we will start from the lower energy level first. According to what principle? Okay, the off-bow principle. Okay, 1, 2, and then second energy level, 2s, 3, 4. Remember, it should have an opposite spin according to the Pauli's exclusion principle. Must have different spin. One is going up and the other is going down. And then, to px. Okay? 1, 2, 3, 4, 5, 6, and then, okay, 7. Sorry. 7. Okay, that's it. That is the electron configuration for nitrogen. Next is oxygen. It has 8 number of electrons or 8 atomic number, and therefore it has 8 number of electrons. So, okay, we have 1 from the lower energy level first. And then 4 na, 5, 6, 7, and then balik na yun ta sa px. 8. Okay. That's it. Okay. Inana siya ang illustration of these 3 principles. The off-bow, the Hans rule, and the Pauli's exclusion principle. Okay? We will proceed to our next topic. Okay, this time, okay, sa maning F. This is fluorine. And Na, this is neon. Okay, fluorine has 9. Okay, 9 iyang atomic number. Therefore, pila ka number of electrons and protons? It has also 9 electrons and 9 protons. Okay, how are we going to illustrate this or look for the electron configuration? We have, okay, we have from the first energy level for energy level 1, 1s, and then identity proceed sa second energy level, which is 2s, and then opposite spin, pila na? 4. Okay, 5. Okay, ang 2p, remember, tulo ka book orbital sa 2p, so 5, 6, 7, balik din ta sa px, 8, 9. Okay. So the electron configuration, para ato na dang ihapon. The electron configuration is sa 1s, pila ka electron? Okay. So 1s, okay, the 1s, okay, duha ka electron kani 1s. How about sa 2s? Sa 2s is duha ka electron. So 2s, 2. Okay. How about sa 2p? Okay, sa 2p, ato na dahil ng ihapon tanan. Sa 2p, pila tanan ka electron sa 2p? We have 1, 1, 2, 3, 4, 5. Okay. So 2p, okay, sorry, nawala kadali ang internet. Yan, nagdaot akong camera. So let's continue. We have kanisha. Okay. This one. Sorry. This one. 1, 2, 3. Murag, ma'am. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So we have 1s, sorry, 1s2, 2s, 2s2, and then 2p. Sa 2px, tunay duha ka elektron. Sa 2py, tunay duha pod ka elektron. Sa 2pz, isa ka elektron. That totals to pila tanan ka elektron. Sa 2p, that totals to 2p, okay, 2p 5. 5. Okay, that is the electron configuration for fluorine. How about neon? Okay, for neon, we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there are 10 electrons. So all of the sublevels are filled. Sa 1s, okay, 1s2. Sorry. 2s2. 1s2, 2s2, and then sa 2px, there are 2 electrons. Sa 2py, there are also 2 electrons. And sa 2pz, there are also 2 electrons. And that totals, sa 2p tanan nga sublevel, there are a total of 6 electrons. So 2p, 6. Okay, 1s2, 2s2, and then 2p6. So these are the electron configuration for fluorine and neon. Okay. So, okay. Now, points to ponder. So we are now on our summary. How does Bohr atomic model differ to the quantum mechanical model of the atom? Again, comment your answers to the question. Second, how does the quantum mechanical model of the atom describe the position of electrons? Still, you can share your answers or comment down your answers below. And then, answer the post-test. Okay? Answer the post-test that is found after the summary. So, assessment, post-test tayo. Okay, so the Bohr's atomic model depicted the electrons as particles in fixed circular orbits. In quantum mechanical model, the location of the electron is not known according to the Werner-Heisenberg uncertainty principle. Instead, probability or the likelihood that an electron will be found in some region or volume around the nucleus. Both models within different distances of the nucleus or shells have different energies. Okay, do not forget to answer the assessment or the post-test. Thank you so much, and that is all for today. See you again tomorrow for our next topic, which is ionic bonding and covalent bonding. Okay, goodbye everyone. Okay.